All right. Everybody sign the attendance sheet. I'm going to break down for you how to figure out this problem. Again, with this algebra situation, it's all about how you set up the problem. So once you set up the problem, it should be easy for you to follow through and get all that information in there. All right. So I'm gonna just go. If there's no does anybody have a preference of which one I do first, or should I just do all of them in order?
Yes.
Just do them all in order?
Yes, please.
Okay. All right. All right. So we're gonna start with number. We're gonna start with number 35. Sorry, I don't have a graph. A graph for it, because that would make it a lot easier for me to help you understand this concept that we're going to be dealing with. But for the most part, we're just going to do what it is that we're going to do. All right, everybody signing the attendance sheet. Let me see if I can set this up.
You say you're naturally artist, so you should be able to.
I should be using my artistic prowess. I should be able to get this thing going. All right. Let me just do this.
Oh, shit, Mom.
All right, so this is the y. That's the y-axis. All right, that's the x-axis. All right, so you know zero is going to be in the middle. All right, I'm going to try to knock this off for you. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 5. All right, I'm trying to make this thing for you as nice as I can. Roberto, do you appreciate my artwork? Is it really nice?
Yeah.
It's good, right?
Mm-hmm.
Okay. It only took 5 years of art school.
You got 6 over there.
There is no 6.
No, I'm just making the graph for you.
Yeah, it only goes up to 5 though.
Yeah. Okay, I'm just making a graph. I'm just making a graph. You know. So it's gonna be 1, 2, 3.
Thank you.
All right, we're making a graph. All right, now what the problem says, we've got line A, B. So I don't have the graphs here. Let me see, what's is there? This the coordinates. There's 1, 2, 3. So we right here, 1, 2, 3. And then it goes up to 3 over here. Look at this point right here. And B is on
-4.
-4. Thank you. All right, so. All right, I'm trying to make a straight line, but I don't. So I'm just going to do my straight line. Just imagine that's a straight line. All right, so that's AB. AB is what that line is called. It says line AB is the left side of a triangle.
A rectangle.
Rectangle, thank you. Whose length is 7 units. If the triangle's width is 6 units, at what point will the upper right corner of the triangle be? All right. Rectangle. Okay. Okay. I'm making sure people are out. Exactly. Thank you. So you can see what I'm doing. I'm glad you appreciate what I'm doing. All right. So look. So the main thing that you guys have to do, you understand the properties of a rectangle. All right. The opposite sides of a rectangle are congruent. That means they're the same side. So that means if they give you this, it's 7. So it's 1, 2, 3, 4, 5, 6, 7 is that side. The other side's gonna be 7. All right, but they said we have to go to what is the width? What is the width of the rectangle?
6.
6. So all that means you have to do is count 6 boxes, right? So we got 1, 2, 3, 4, 5, 6. So we got this line.
So how do we know that? I mean, how do we know that that's where we're counting from? Where is the start? Where is our starting point?
The starting point.
Where do we start? Where do we start counting from?
It's a rectangle. It's a rectangle. All right. So you know do you understand the shape of a rectangle?
Yes, I understand.
Okay. So the rectangle is going to be from point. They're giving you points A and points B. So if you count from point B over here, that'll give you the width. Then you go from this point, that'll give you the other length, and you go from that point, that'll give you that. All right. So they're giving you the information. This is 7, so you can count this out as 7. It's minus 4, right? So you got minus 3, minus 2, minus 1, minus 0, and then you got 1, 2, 3. So that's 7 units, 7 boxes. All right. Going the other way, it's going to be the same thing. You're going to count 6 boxes. All right. So we got 1, 2, 3. What is this at? This is at minus 4, right?
Yeah.
So 1, 2, 3. So now we're here. We're 1, 2, 3, and then we got 1, 2, 3.
So it's gonna be positive 3.
Right. This point, and for people that don't know how to do these points, let me just write these points out for you. This point here, this point B is actually, you would write it like this: minus 3.
Minus 4.
Right. Minus 4. Because it's X and it's Y. All right? X and Y. All right? So this point here is going to be plus 3, still minus 4. All right? So we have 3 minus 4. All right? So we can draw up, this is our, that's our width. All right? The next point is going to be, still, what's this at? This is at 3 over here, right? So we got 1, 2, 3. Then we got 1, 2, 3. So, using our formula or whatever that they got for us, all right, when you plot this, they want to know, they really want to know what this point is. The point of the rectangle. I'm going to draw the line. We got A, B. I'm going to just call that point C. And this will be point D. Fabiola is doing your favorite subject.
I know.
You know he's doing your favorite subject?
I can see.
Okay, all right. So, if you look at that, they're not going to give you the answer, but this point here, this point is
Positive 3.
right. It's positive 3 and positive 3. So that point would be 3, 3. All right. So if you look at your book and check your answer, this is a rectangle. Both of these sides are congruent. This side.
And where do we check our answers in the book?
Wait, that's a rectangle? Or that's a square?
This is a rectangle. Because this is it's 7 by 6, so it's close to a square. If it was 7 by 7 or 6 by 6, it would be a square. But it's not. So this is a rectangle. All right. So somewhere in the book, they're going to show you. What they're going to show you is they don't have this all mapped up, but they're just going to show you this point right here, which is going to be 0.33. All right. So I'll give you a second to digest that information while we try to figure out
It actually shows you the math on page 903. It shows you the math.
Okay. So this is you see that's the correct answer that they want. is right there in the corner. So it's just about plotting the points, and then you don't even, I plotted the points for you. You really don't even have to plot the points, because all you really need to do is know where that point is.
So you don't really need to write the answer down, because all they want you to do is to put where the
Right. So that's why you see I made the square.
Right.
So this is the point they want. This point is 3, 3.
Okay.
Now just because they didn't ask you for the point this time when you take the test, they might ask you what is the coordinate.
Okay.
What are the coordinates? So you would say that's 3, 3. All right. But they didn't ask you. They didn't ask you what B was. I gave you A, C, and D. But that's how it is. So anytime you get those questions about positioning, they're talking about units, is the boxes. The boxes are a unit. All right? So any questions? We're on page 895. We're on page 895. All right, so any questions about this? Was relatively easy. It was just a matter of counting boxes. All right, and knowing some information about geometry, about the rectangles, that the opposite sides are congruent or the same size. So once they gave you this is 7, you know this is 7. Once they gave you that the width is 6, then you just basically have to count 6 boxes over. So you could have did this. You could have did this all not in your head, but you could have just did it all in the map. You see how it works out? All right, simple, right? All right. So are we ready for the next challenge? We ready for this next one?
Yes.
All right. Now the next one is an algebraic situation. All right, I'm going to erase this if everybody's got it, because I just do this. Algebra. And it's simple algebra. So I'm going to call contestants from the audience to assist me in my endeavor. So what's it? 3x minus 1 equals 11. 3x minus 1 equals 11. So they said if 3x minus 1 equals 11, that's how the problem starts. If 3x minus 1 equals 11, what is the value of x squared plus x? All right, so put x squared plus x over here on the side, so we know that's what we have to solve for. All right, now, algebra.
It's 5, right?
No. But let's not call out. We're gonna call on y'all to get some situations going. All right, so Adriana, what's the first thing that you need to do?
Solve for x.
What I'm saying, what is the first thing that you need to?
Cross it out. You have to take it out.
What do we take? What are you gonna take out first?
The 3.
No, that's not the first thing. What do you think the first thing is, Sharia? Get rid of the 1 first. How you gonna get rid of the 1?
I don't know. I'm going with that one outside.
You're going to add it on both sides?
You have to add 1. You want to get the x by itself, so you got to add the 1 to both sides. So that's the first thing I'm going to do. I'm adding 1. All right? So when I add 1 to this, that's going to be 0. That's going to give us 3x equals, and I'm adding 1 to this. 11 plus 1 is how much?
12.
12. All right. So, Carmen? What's your name again? Carmen, right? Oh, okay.
Get the 3x.
Say it again?
The 3x.
No, because this is what we started with. We started with 3x minus 1. So the first thing we want to do is get the x by itself.
Okay,
so we got rid of the 1 first. So we added 1 to both sides. So that makes that 3x equals 12.
But teacher.
Yes.
I said the answer of 36 is 5, and you said no.
It's not 5.
It's 5. You see 1, 2, 3, 4, 5.
Okay, well I'm just 5. Let's work it out, because I don't know what you're talking about. The answer is not 5.
20.
Yeah, it is 5. What I mean 5, the
Right, yeah.
circle.
Okay. All right.
It's 20.
All right. So let's get to this for the people that didn't get it. Let them get it. All right. So now we got 3x equals 12. Francine, do you know what we're going to do next?
That's it. Check.
Adriella, what are we going to do next?
Don't you have to put 1 over 3 to get the x by itself?
Exactly. So the next step of the equation, we want to get the x by itself. So remember the word, what's the word that I gave you before? Say it loud, student of the month. What is that word?
Reciprocal.
Thank you. Reciprocal. We're going to get the reciprocal, which is 1/3. So we do 1/3 on that side, we multiply 1/3 on that side, we do 1/3 on this side. So that's going to get rid of the 3's, it's going to cancel out. Alright? So that's going to give us x is equal to, what is x equal?
4.
X is going to equal 4. Because this is going to give you 12 over 3. That's an improper fraction, so then whenever you have this, you have to divide the numerator by the denominator. So 12 divided by 3 is 4. Alright? So that's how we get to 4.
How you get to 20 times?
Because now we have to solve for the other fraction. What they asking for
Right. See, remember this? And see, that's all right, wrote this on the board. This is what they give. They said if 3x minus 1 is 11, then this is what they call an if-then problem. If 3x minus 1 is 11, then x squared plus x equals what? So, what is x? Francine, what's x? 4. So how much is 4 squared? 4 times 4 is?
20.
4 times 4,
16.
16. And then 16 plus 4 is?
20.
20. So if you check your book, that'll be the answer. And see, that's why I'm trying to break it down step by step. So if you didn't know how to figure out that problem.
Okay.
All right?
I still didn't get that.
All right, it's not a problem. I can do it over. Yeah, I can do it over. All right? So I'm gonna leave my word reciprocal on the board, Tans, because I'm calling you for you to tell me what that word is.
You're not calling me to ask me that. I just want you to do that again.
I will call on my other student of the month, Roberto, and he will help me. All right, now look. Again, this is what they call an if-then situation, or problem, or equation, if you want. They're giving you this information. They said if 3x minus 1 equals 11, how much is x squared plus x? All right. So, going back again. Roberto, what's the first thing we have to do?
Add it.
Add what?
Plus x plus 1.
All right. The first thing, listen. The first thing that you want to do is, in any algebraic situation, you want to try and get. In any algebraic situation, you want to try to get the variable by itself. So the first thing you want to do is get rid of this. This is extra stuff. So anything plus this, minus this, whatever it is, that's the first thing that we're going to get rid of. All right. So Adriana, how are we going to get rid of that -1? What do we have to do?
You're gonna add 1.
We're going to add 1 to each side. So I'm going to put that right here. So I'll put a +1 here. I'm going to put a +1 here. All right. So then we're going to get 3x equals +1 and -1, they cancel out, so that's 0. So that's going to be blank. How much is 11 plus 1, Tans? Okay, 12. So now we have 3x equals 12. What do we have to do now, Carmen? ¿Qué tenemos que hacer?
You gotta put 1/3, 1/3.
Right. Because the next thing we got to do, we have to, what's that word that's on the board?
Reciprocal.
We got to get the reciprocal of 3 so we can get the x by itself. That's the whole purpose of all these algebraic equations. You want to get the variable by itself, whether it's x, y, z, p, h, d, me, g, all right. Whatever it is, you want to get the x by itself. So, Carmen said we need the reciprocal of 3, which is 1/3. And what you do to one side, you got to do to the other side. All right? So when we do this, that's going to cancel out. That's going to give us our x by itself. When we do this, this is going to give us, when you multiply 12 times 1 over 3, that's going to give you 12 over 3, which is an improper fraction. So whenever you have an improper fraction, you must divide the numerator by the denominator. That's what you always do. You have an improper fraction. So Francine, when I divide 12 by 3, what do I get?
4.
4. All right, and that's our answer. X equals 4. X equals 4. So we solve for X. So it says that this, if X, and let's check this out. Let's go back and see. That's the thing about math. You can always go back to the equation and check to see if your answer is right. So we got 3x minus 1 equals 11. So how much is 3x?
1.
3x is, so we got 12 minus 1 equals 11.
That's right.
It looks like it's right. Let me see. Let me just see, just to check. I'm going to add, I want to solve, I'm going to add 1 to each side. And that's going to be 12 equals 12. All right? So we know that we have the right answer. We check. We know we have the right answer. Now we're going to proceed to the next phase, the then phase of the problem. So it says, if 3x minus 1 equals 11, then solve for x squared plus x. So, Sharia, what is x squared? What's that going to be? She said x squared is really, anything squared is 4. 4 times 4 plus 4. All right, anything squared is the number times itself, right? This is a fancy way of saying whatever times whatever. All right, so 4 times 4 is 16. 4 times 4 is 16 plus 4 equals 20. All right? So that should be, as Fabiola said, that is number 5. Right, Fabiola?
Yeah.
She said that's number 5. I know what you was talking about, because I think you said the answer's 5.
I didn't mean it as 5. I meant it's
Right.
5.
No, I got you now. I understand. All right. All right, so now we're going to do this. Now the next one is going to be crazy. But I'm going to set it up for y'all, and you're going to figure out how it works. It says the bell rings every 2 hours, the second bell rings every 3 hours, and the third bell rings every 4 hours. All right, if all bells ring at 9 o'clock, at what time will all 3 bells next ring?
Ring next.
All right. It says next ring. But thank you. All right. Now here we go. We're going to set this up. What's the problem? What's the problem we did? Remember the velocity problem? Remember the problem with the cyclist? The one bike guy starts 3 hours later, and then that's how you said. That's what this problem is. So
I did it, just like you did.
You did it?
Mm-hmm.
Okay, that's excellent. That is excellent. All right. You're gonna get an A on your next test. All right. So it says they all start at 9 o'clock. All right. So now let's put that down. 9 o'clock. Everybody rings at 9 o'clock. So bell 1. Bell 1 is
2.
every 2 hours. All right, so I'll put it on top. Every 2 hours. All right, then we got bell 3. What's bell 3? I mean bell 2.
Every 3 hours.
All right, every 3. And what's bell 3?
Every 4 hours.
No, it's probably going to be, probably want to be in, well, let me just work it out for you. Every 4. All right, here we go.
It's a 12 hour maximum.
All right, so look. So all these bells are ringing at 9 o'clock. So 9 o'clock.
I put a 0 for that one, and you're gonna know.
All right, look. All right, so all the bells are ringing at 9 o'clock. That's how we're doing it. All the bells are ringing at 9 o'clock. All right. So we got 10 o'clock. Which bells ringing at 10 o'clock?
None.
None of the bells are ringing at 10 o'clock because this one is every 2 hours. At 10 o'clock, nobody's ringing. This guy's not ringing, this guy's not ringing. All right. I'm going to draw the line just so to make it easier for you to see. At 11 o'clock, is anybody ringing at 11?
Yes, the first one.
First one rings at 11. First one rings at 11. This guy's not ringing.
No.
This guy's not ringing. Like I said, I should have made this thing smaller because maybe I'm going to fit everything on here. We're going to figure it out. All right, so draw another line. Okay, now it's
12.
It's 12 o'clock. Is this guy ringing at 12 o'clock?
No.
No. Is this guy ringing at 12 o'clock? Yes, this person is ringing at 12 o'clock. Is this person ringing at 12 o'clock?
No.
No. All right. Now the trick is we're trying to figure out what everybody's going to ring again. All right. I could have did this a simpler way, but I'm doing this so that y'all can see how it works. All right, because this is a mathematical equation that you can use and whatnot, where they're going to ring at. All right. So
Now it's 1.
it's 1 o'clock now. Time is fine. I thought it was 9:30.
I know, 1 p.m.
Oh, but it's 1 o'clock. Okay, well, you know what? I'll put PM here. Just in case anybody wants to try this at home, they can do it. All right. So, is this, Adriana, is this person ringing? Is this first bell going to ring?
I'm sorry. I wasn't paying attention.
Okay, not a
Yes.
problem. It's going to ring because it rings, it rings every 2 hours. All right? Every 2 hours it's going to ring. So, it's not this hour, but the next hour. Not this hour, but the next hour. So that person is going to ring. So imagine that this person is not going to ring.
No. Yes.
No, this person is not going to ring.
The other one, yes.
Oh, this one, 1, 2, 3, 4. This one's going to ring.
Yeah.
Okay. All right. So you're saying yes, and I'm saying, what are you talking about? All right, so I got you, Fad. All right, so now we're moving on. All right, so it's 2 o'clock.
No.
It is 2 o'clock. How you saying no?
For all of them?
It's 2 o'clock. So does anybody ring at 2 o'clock?
No.
All right, 2 o'clock, nobody rings. 2 o'clock, nobody rings. All right. 3 o'clock. Anybody ringing at 3 o'clock?
Yes.
Yeah.
Who's ringing?
2 hours.
The one that rings every 2 hours is going to ring.
And the one 3 hours too.
And you said the one that rings 3 hours?
Yeah.
Okay, he's going to ring. But the one that's every 4 hours?
No.
Okay. We're going to be doing this. We're going to be doing this for a minute. But we're going to get the right time. We're going to get the right time.
We're going to get there at the same time.
Huh?
We're going to get there at the same time.
Yeah, so we're all going to get there at the same time. All right, so 4 o'clock p.m. All right, anybody's ringing at 4?
No.
Nobody rings at 4. All right. No, it looks like something's happening. Something's getting ready to happen.
Somebody's going to ring at the same time at 5 o'clock, maybe.
Right.
Yeah.
That's what I'm thinking. I'm thinking like you. Somebody's going to ring at the same time. So at 5 o'clock.
It is.
I can't even see.
At 5 o'clock.
Number
Francine,
2.
is this person going to ring?
No.
First one's not going to ring?
Yes.
I don't know. Sheree, what do you think?
Yeah.
Yes.
Sheree says yes. What about this one, Carmen? Is this one going to ring? Carmen?
No.
The
No.
first bell and the third bell going to ring at the same time.
First and third bell. Okay, so this one here is gonna ring. All right. All right. I'm just wondering. This one here got to ring soon.
Now it's 6 o'clock.
He's gonna ring. I know what time.
Same time.
I know what time he's gonna ring, but I don't want to tell y'all. I want to keep you in suspense. I want to keep you in suspense.
Yeah.
All right. Are y'all in suspense? And suspend the animation. All right. So look, 6 o'clock. Does the first one ring at 6 o'clock?
Yeah.
No.
No.
No, the first one doesn't ring because it's every 2 hours. See, it rings, then it doesn't ring. It rings, then it
Yeah.
doesn't ring. All right. So this one does not ring.
It doesn't?
No, because it just rang last hour. What about this one? Does that ring?
Yes.
All right. Because this one rings every 3, right?
Yes, I see what you're doing now.
You see what I'm doing? See how I set it up for you? All right. What about this one? Is this one gonna ring?
No.
No.
No. All right, we're getting closer. I'm thinking if we got enough space for 9 o'clock, we might have something.
We just keep going down under the board.
Right. We just gonna keep. I just keep going down right here.
Yeah.
I'll just keep going
I'm
down.
gonna be sure that you are keep going.
Okay. All right. I can work with you.
I'll do it for you.
You gonna do it for me? All right. All right. Let's go. 7 o'clock.
Yes.
7 o'clock. Guess what? What's gonna happen, Francine?
It's going to ring.
Which one's gonna ring?
The first one.
First one's gonna ring at 7 o'clock. Okay.
Yes.
What about the second one?
No.
Second one is not gonna ring. What about this third one?
Yes.
What about the third one?
No.
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 Okay, you know.
Okay. We're getting there. We're getting
9
there.
o'clock.
We're getting there. Let me see. We might not get there together, but we're gonna get there. All right. So now we at 8 o'clock.
They
No.
also.
8 o'clock p.m.
No ring.
No.
First one doesn't ring.
No.
No.
What about the second one?
No.
Second one doesn't ring. What about the third one?
Yes.
Mm.
No.
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 Oh, okay, right. Okay.
All right.
How'd you know?
Getting close.
And they will ring after the class. Excuse me.
All right. All right. Now, everybody, brace yourself. The moment of truth. The moment of truth is coming. Let me just check. Because I told you I was going to run out of space. And I try to be so slick with my stuff. All right, 9 o'clock p.m. Is the first one going to ring?
Yes.
First one is going to ring.
Yes.
Is the second one going to ring?
Yeah.
Yes.
The second one's going to ring?
Yes.
Mm.
All right.
And the third.
And the third one's going to ring too?
Oh.
Yep.
All right, so we figured that out. So at 9 o'clock, all of these guys are going to be ringing. At 9 o'clock. So that's the way you set that problem up. So that way you can see exactly what's going on. And if you check the answers, I don't know who's checking the answers, it should be 9 o'clock. Oh, there's the answer right there. It says 9 o'clock. Fab, is that the right answer? They usually check the answer.
It says it.
No, I'm saying that's one of the choices.
Okay.
That's one of the choices. I mean, that means that,
103.
that was 30, 37.
Yeah, that's right.
9 o'clock. All right. All right, so can I get rid of this now?
Mm-hmm.
All right, everybody's got, so I'm erasing the board. Ladies and gentlemen. And I'm hoping that you guys are copying the formulas and the formats and how I'm setting this stuff up. Because when I give you your homework, you're going to have to do this at home by yourself. You know what I mean?
Okay.
Question. You got a question?
38. I found the answer, but I had to use the answer they gave me to find it.
Which one is 38? Is that the next one I'm doing?
Yeah. I want to know how
How to figure it out?
to put it down algebraic, not to go to the answer to find it. Is that
Okay, not a problem. Not a problem. That is why I am here. And I'm gonna show you how to get that answer. All right. You're gonna figure out I'm gonna show you how to get those answers. All right, so that's the one with the percentage, right? Yes? No? Percentages?
Yes.
That's percentage. All right, let's go. It says a family spends, this is how you set this up. They spend 20%. Now, it really doesn't matter to me what they're spending the 20% on. Could be beer, drugs, wine, sangria, whatever. All right, that doesn't matter to me what they're spending the money on. The only thing that I'm really concerned with is the percentages. All right? And what's the last one? Is 42%? Yes. All right. So, that's 85%, right?
How about 85% of X plus?
No. You're gonna.
That's what I'm stuck
Right.
on.
All right. Now, here's the key. They're telling you that. But what's the information they're giving you? How much? What they're trying to figure out? They tell you how much you save.
Expenses will save with the balance if the family saves $360 per month. What is the monthly income?
All right. So they got 300. So this is the whole thing you're doing. You got $360 per month. That's what you're saving, right? And that's a fraction over the money that you're getting, all right? Which is going to be equivalent to 15% over 100%. Question?
Isn't it, just a question. To find out the percentage of this, wouldn't it be to deduct like 100 minus the 42 minus the 23 and the 20%, which that's what they're spending overall?
Are you asking me something, or are you making an observation? Did you see what I did?
No, I saw what you did. My question is, it says if they spend 20 on food, 23%.
Do you see that over there?
Yes.
Okay.
So
you take you got 85%, right?
Right, that's 85%.
So that's 115.
Thank you.
And you divided that in 100, which is 1500.
Right.
Minus the what?
All right, so what she's asking is what I did. You're asking me, and that's what I did.
To me, that's what I see.
Yeah, exactly. You're saying exactly right.
Yeah, all that, and then to get to 100 is 15.
So that's what's missing. So this is our equation. You have $360, which is 15% of X. $360 is 15% of X. All right. So now what we're going to do is we're going to solve for X. So what I'm going to have over here, I'm going to have 15% X equals. I can get rid. You know what? I'm gonna get rid of that percentage sign in a second. Let me just see how it works. It's gonna be 3, 6, 0, 0, 0. All right. All right. So this is what we're working with. We got a 3,600 over here. 36,000. We got 36,000 and 15%.
You just cross multiply that?
That's what I did.
Okay.
All right. So now, Adriana, you're gonna divide, because you know we gotta divide this. We want to get X by itself. That's gonna be 3,600 over 15%. All right. All right. So yes. So we're dividing 0.15 really into 36,000.
So 2?
Say again?
Two.
Two
You
what?
go for, how many times 15 goes into 36?
Okay, so that's, I'll go for that. That'll be 2.
2, and then 30, then 6, and drop the zeros.
And then that's going to be 4.
4 goes to 60.
All right, so that's going to be your answer. So if you look on that paper, right, so $2,400 would be,
Oh, okay.
that's what that is. All right, because you're dealing with, basically you're dealing with proportions and ratios. So it's basically saying this is to X as 15% is to 100%.
Okay.
So you can see that the answer is 2,400 is on your thing, right? So Fab, did you see how I worked it out? All right, so you got it now?
360 over the X equals 15%. I just take 360 times 100 divided by 15, that's it.
That's what I did. All right. You need help over there, Cash?
Oh.
So percentage of division?
Yeah, but remember I told you a percentage is always division, because percentages is whatever that number is over 100. And then percentage is division, and fractions are always division. It's whatever that number is divided by the denominator is how many parts it is. Okay? All right. All right, we're moving on to the next one. All right.
All right, can you explain one more time?
But of course. You want me to explain one more time?
Yes.
I was just waiting for y'all to finish your conversation, and I was going to explain it for y'all. All right, look. Here's the thing. They're giving you, these are the numbers that they're giving you. 20% on groceries, 23% on alcohol, 42% on drug abuse, whatever they're doing. That's 85%. All right? Which leaves you 15%. All right?
How you got 15%?
Because anytime, you always have to put that they're subtracting it from 100 whenever you see percentage. So you add all the percentage that they're giving you. 20 plus 23 plus 42 is equal 85% out of 100. Whenever you see percent, you always think in your head that you have to subtract that from 100%. You understand that?
Let's say if you have in there 25.
Right.
I mean 50.
Right.
Right?
So you subtract 50 out of 100.
Right.
And another 42.
So I mean, after a while you're going to get to know all the relationships between these numbers. I mean, it's like money. If you got 85 cents, you know you need 15 cents to get 100.
off.
All right.
So it's half of everything. So you always see that from 100.
Okay.
So from 100, that's a whole percentage minus this. That's what they spend monthly. That's total, 85%. So 100 minus 85% is 15. You always think whenever you see percentage, you put the 100 minus whatever it is. In this case, 85%. Whenever, it's always from 100. You're always taking whatever percentage from 100.
Okay.
All right.
Okay.
So we have the ratio or the proportions or whatever. $360 over X, which is the total number that we don't know, is going to be the same as 15% over 100%. Because this X is all their money. This 360 is 15% of all their money. This is all their money, and that's 15%. All right. So if we cross multiply, which I did, you're going to get 15% of X equals $36,000. Then that's going to give me 15%. 36,000 over 15%. Remember I said whenever you have a fraction, it's division. All right. So we're dividing here. We got 15%. That 0.15 is 15% into $36,000. All right. So 15% of 36,000 is going to be 2,400. All right, and we could do that. Let me see. We can go backwards and say for 85%. All right. So, but that's how you work it out. What do you need, Tan?
Sharpener.
All right. All right. So, any other questions about this? How to check this or work something out? We good? You ready for the next one? You ready for the next? The next one. It's kind of the same. It's kind of the same type situation. All right. Let me draw this thing. Let me draw this thing on the board. I'll help you all to see it. All right. They're telling you you have two parallel lines. Parallel lines are AB and DC. AB. AB, and then we got DC at the bottom. AC. All right. So they give us this at AB parallel DC. So that's what they give you. AB is parallel to DC. You're saying that AB is equal to 60 feet. Where you at? 60 feet. It's giving us this X. I mean, I'm missing some information. What it says BD, what does it say BD does? Don't give me anything about BD. It says EB. Let me just draw this. We got two lines. Let me put these two lines here. We got DB, and then we got AC, and then we got this here is point E. We got E there. So they're saying that DE is 80 feet. 80 feet. This one here is 48 feet. 48 feet. And what else are they giving us? They're going to give us something else. Circles to measure the distance point A. All right, so they gave us the things that are parallel. All right, now look. What they gave us, ABE, is similar to DEC. Triangle ABE. Triangle ABE. Similar to DEC. All right. All right. Now here's the situation.
What are you doing?
bottom of AB would be, is that an A? What is that?
What are you talking about?
What the hell, what you just wrote?
Triangle
Oh, okay.
ABE is similar to triangle
Okay.
DEC. All right? So I just want to make sure I'm getting all information. To measure distance across a pond, a surveyor takes AB, so AB is parallel to DC. 48 ED equals about 5 feet. Mark your answers on the thing. All right.
You say ABE is similar to what?
DEC. That's the information that they're giving us. So they said they want to find what, we got to figure out what DC is in feet. All right. So, what's going on here, people, is that they're trying to say that both of these triangles are the same. Right. They're trying to say that both of these triangles are the same, exactly the same. So that means they're dealing with the same proportion. All right? They're dealing with the same proportion. So what that means is what that means is
isn't it? Don't you have? Isn't it total 100?
What are you talking about? It's total 100.
When you have like this, these distances, don't they have to be equal to? If A to B is equal to 60 and D to C is bigger than A to B, so don't you just have to add like what's missing to complete the 100?
What 100 are you talking about? There's no 100 on the page.
I know there isn't. Okay, see how
Well, why don't you do this? Why don't you let me show you how to work out the problem first, and then if you have any questions after I work out the problem, you can deal with it like that.
Okay.
Okay? Let's try that first. All right. Now here's the thing. They're telling you that these triangles are similar. All right? Meaning that the relationship or the ratios of the triangle are similar. All right? So there's a few ways that we could do this. All right? We could do x over 60.
Can you erase all the other stuff on the board, please?
Definitely.
Thank you.
All right.
You said X over 60.
All right. I think that's the way I want to do this one. Right. I just flipped the numbers by accident. Because it's 48 over 60, and then it's going to be 80 over x.
Yeah.
So that's going to be this. So that's going to be 48 x equals. All right. So that's going to be 100 equals
That's
x.
you said back there.
Yeah.
He was right. I just listened to everybody.
Yeah. No doubt. I mean,
But it's just that everybody talks. Everybody's trying to get it in.
Right.
You got it. You
Right.
just want to pull it out at one time. But there's other people that don't really get it.
Right.
But it's okay.
No,
That's why
doubt.
you're here.
Exactly. And see, that's what is 80 over x. That's what's supposed to be 80 over x, and then the 48 over 60. And see, I put the x over 60. But that should have still came out. No, you put this up here, Fabiola, right? You wrote this?
No, you did. I just exchanged that side.
No, because I'm just saying. If I did this, that was right.
You didn't. The 48 was on top. And
No, I'm saying no, but this
right there.
I'm saying right here. This,
yeah,
that's still
it was
right.
good, yeah.
That's
It's
still
just the other one, you flip it around.
right. Because when I did this would have been 48x right here and 4800.
Yeah.
Yeah. So I don't know how I messed that up right here. That's why I jammed up right here with the 1.5. All right. So we still get the right answer. All right. So that's still a way to do it. All right.
So
So
X.
X is going to be X is gonna be 100.
100.
X is gonna be 100. All right, so that's how you figure it out. It's still with the proportions. All right, so it's still gonna be X to 60. So I had to set it right. X is to 60. That's 48 is to 80. All right, X is to 60 is 48 is to 80. So I put the X on top. So the 80 goes on top, 48 on the bottom. So I had that right. I don't know how I got this.
You didn't. I'll write that. That's my handwriting.
You wrote this.
Yeah.
That's why I asked you. I asked you in the first place. Yeah, that's why I asked you in the first place.
Oh.
All right, but so it's still. So I got the 80 right here, 80 over X multiplied. It's still coming out right. All right.
No.
You know what?
Didn't get it.
A lot of stuff going on. Craziness. All right. What's the next problem? I am. This is true. This is true.
I don't think
X plus 8X.
What you was gonna say, President?
nothing. I'm gonna keep that to myself.
Yeah, I know what you're gonna say, and you're 100% right.
Yeah.
Yeah, you're 100% right. But that's how.
You got that.
Yeah. But that's how many.
So let's go to 4. We can leave that alone. Let's finish work.
All right. So which one we gonna do next?
286, man. Oh, you said just do 40. But just